So let's actually try to calculate one of these line integrals. So I've got the line integral of 2 plus x squared y ds, where c is the curve x squared plus y squared equals to 1. So the first thing you're going to want to do with any of these line integrals is to parameterize your curve. So our curve is x squared plus y squared equals 1, just a circle with radius 1. We know how to parameterize that. That's just the unit circle. So my parameterization for c is going to be x equals cosine and y equals sine. T is kind of taking the place of what we normally think of as theta in the unit circle. And then we know to get the whole unit circle, we want theta, or T in this case, to go from 0 to 2 pi. All right, so that's our parameterization. So our red box down in the bottom says to plug that parameterization in to our function f of x. So we're going to integrate 2 plus x squared y. So this is 2 plus x squared. In our parameterization, the x component is the cosine of t. So I'm going to have cosine t squared. And then the y is sine t. So I've got sine t. All right, so that's my 2 plus x squared y. And then my limits, I'm going to convert this whole thing into t. So I'm going to say we're going from 0 to 2 pi. All right, so in the middle line of my formula down here, we need to have this magnitude of r prime of t. So let's calculate r prime of t over here. R prime of t, derivative of cosine is negative sine, derivative of sine is cosine. And we need to put the magnitude of that vector into our integral. So I know the magnitude is going to involve a giant square root over here. So I'm going to have the first component squared, and just taking the magnitude of a vector, plus the second component squared. And at the very end of this, we're going to put a dt. All right, so just from our formula, this is our f of g of t comma h of t. And this is my magnitude of the derivative of my parameterization. Whew. All right, so let's see what we can simplify in this. I've got integral from 0 to 2 pi, 2 plus cosine squared times sine. And then I've got square root of sine squared plus cosine squared. And thankfully, we have a nice curve. That square root is just the square root of 1. So I've just got the integral from 0 to 2 pi of 2 plus cosine squared t sine t dt. All right, I've run out of room. So let's go copy this onto the next slide. So here's where I was at the bottom of the last slide. I've got two things to integrate here. I've got a 2. That's really easy to integrate. That's just 2t. But then I've got this integral of cosine squared times sine. I'm going to have to handle that with a little u substitution. So I'm going to come over to my scratch work and work that part of the antiderivative. So I've got cosine squared t sine t dt. So I'm going to handle this with a little u substitution. I'm going to let u equal cosine t. And then du can be negative sine t dt. And then I've got everything I need. I just need to have a negative sign on my sine function. So I'm going to put a negative in here and compensate with a negative on the outside. And then negative, and then the sine t dt, all of that's going to get sucked into the du. And that leaves me with a negative on the outside. Integral of cosine squared is going to be u squared. Everything else got pulled into the du. So this is a pretty simple integral once we get the substitution going. And I'm going to have u cubed over 3, which is negative cosine cubed t over 3. And that's my antiderivative that needs to go for the second part of my integral. So I actually need this to be a minus cosine cubed t over 3. And we're going to evaluate this from 0 to 2 pi. All right, so let's plug in 2 pi and plug in 0 and see what we get. So I've got 2 times 2 pi minus cosine cubed 2 pi over 3. And then plug in 0 everywhere. All right, so I have in my first set of brackets 4 pi. Let's see, cosine of 2 pi is equal to 1, and 1 cubed is just 1. So this is going to be minus 1 cubed. And then 2 times 0, my second bracket, so that's 0. Cosine of 0 is also equal to 1. So 1 cubed is 1. So minus 1/3. And let's see, so I've got 4 pi minus 1/3 minus a negative 1/3. Okay, so all of that cosine stuff canceled out in the end anyway, and we just had a 4 pi left at the beginning. All right, so I want to just go and show you a picture of what we calculated over in Mathematica. All right, so here we are in Mathematica, and I have graphed here the orange surface. That's our function 2 plus x squared y. And then on the xy plane down on the bottom, I've got that unit circle drawn. And then just like we saw in the other applet, what we've been calculating here is the area of that curtain. This one's a blue curtain hanging down below that function over the curve x squared plus y squared equals 1 down in the xy plane. All right. So we'll calculate a few more line integrals when we meet together in class next time.